Bismillahirrahmanirrahim. Today my presentation topic is nano fertilizers. Presented to respected Dr. Hammad Majeed. Presented by Sayyid Ahmad Hasnan, that's me. So first of all, these are the contents of my presentation topic. First of all, I discuss introduction of my topic, methods of encapsulation, types of nanofertilizers, its benefits, limitations, types of regular fertilizers, and difference between conventional and nano fertilizers. Conventional fertilizers and nano fertilizers. So first of all, what are nanofertilizers? Nanofertilizers can be defined as nanoparticle encapsulated materials which slowly delivers nutrient to crops. Nanofertilizers are nutrient carriers developed using substrates with nano dimension of 1 to 100 nanometer. Nanoparticles have extensive surface area and capable of holding abundance of nutrients and release it slowly and steadily such that it facilitates uptake of nutrients, matching the crop requirement without any associated ill effects of customized fertilizer inputs. Methods of encapsulation. Different kind of encapsulation methods include encapsulation of nutrients with nanomaterials like nanotubes or nanopores materials, coating of nutrients with a thin protective layer of polymer, formulations which can deliver nutrients as particle or emulsion of nanoscale dimension. Types of nanofertilizers. There are three types of nanofertilizers. Nanoscale fertilizers are made of nanoparticles that contain nutrients. Nanoscale additive fertilizers are traditional fertilizers with nanoscale additives. Nanoscale coating fertilizers are traditional fertilizers coated or loaded with nanoparticles. Types of nanomaterials. Carbon based nanomaterials. The previous one is types of nanofertilizers and these are the types of nanomaterials. Carbon based nanomaterial is the type of nanomaterials. These nanomaterials are composed mainly of carbon. Commonly the forms are hollow spheres, ellipsoids or tubes. Carbon-based nanomaterials with spherical shape are called fluorines and those with cylindrical shape are called nanotubes. Metal-based nanomaterials. These nanomaterials include quantum dots, nanogold, and nanosilvers, and nanooxides, and metal oxides such as titanium dioxide, zinc oxide, magnesium oxide, iron oxide, etc. Dendrimers, nano-sized polymer of branch units with large number of chain ends on its surface. It can be used as a catalyst and its three-dimensional structure with inner cavities allow us to use dendrimers for drug delivery by placing the drug molecules inside. Nanocomposites, a formulation obtained by combining nanoparticles with other nanoparticles or with large bulk type materials. These are generally used to enhance mechanical, thermal barrier, and flame retardant properties of other materials. Benefits of nanofertilizers. They regulate the availability of nutrients in crops through slow control release mechanism. Such a slow delivery of nutrients is associated with the covering or cementing of nutrients with nanomaterials. Furthermore, nanofertilizers reduce the need for transportation and application costs. Another advantage of using small quantities is that the soil does not get loaded with salts that usually are prone to over application using conventional fertilizers on a short or long term basis. Another advantage for using nanofertilizers is that they can be synthesized according to the nutrient requirements of intended crops. In this regard, biosensors can be attached to a new innovative fertilizer that controls the delivery of the nutrients according to soil nutrient status, growth period of a crop, or environmental conditions. Nanofertilizers increase the bioavailability of nutrients through their high specific surface area, miniature size, and high reactivity. On the other hand, by providing balanced nutrition, nanofertilizers enable the plant to combat various biotic and abiotic stresses with overall clear advantages. These are the benefits and limitations of nanofertilizers. In my left hand side, the benefits of the nanofertilizers, and on my right hand side, the limitations of the nanofertilizers. So first of all, benefits: slow control delivery of nutrients, reduce loss rate of nutrients, increase bioavailability of nutrients, synthesize according to the objectives, highly nutrient efficient crop. And the limitations are high reactivity and variability, environmental impact, safety concerns for farm workers, safety concerns for consumers, at no cost for human health and the environment. So, types of regular fertilizers. Mineral fertilizers. The European fertilizer industry transforms millions of tons naturally occurring raw materials such as air, natural gas, and mined ores into high quality plant nutrition products. Nitrogen fertilizers. The main product are nitrogen based fertilizers such as ammonium nitrate and calcium ammonium nitrate, which are well suited to most European soils and climatic conditions, and urea, ammonium nitrate, aqueous solution widely used in other parts of the world. Other citrate nitrogen fertilizers include ammonium sulfate and ammonium sulfate nitrate, calcium nitrate, sodium nitrate, Chilean nitrate, and anhydrous ammonia. Types of regular fertilizers. The second one is phosphorus fertilizer. The most common phosphate fertilizers are single superphosphate SSP, triple superphosphate TSP, monoammonium phosphate MAP, diammonium phosphate DSP, and ammonium polyphosphate liquid. Different fertilizer products have different release profiles and need different spreader setting for efficient application. Potassium fertilizers. Potassium is also available in a range of fertilizers which contain potassium only or two or more nutrients and include potassium chloride, potassium sulfate or sulfate of potash, potassium nitrate known as KN. Calcium, magnesium and sulfur fertilizers. Calcium, magnesium and sulfur are essential secondary plant nutrients. They are not usually applied as straight fertilizers but in combination with the primary nutrients nitrogen, phosphorus and potassium. Sulfur is often added to straight nitrogen fertilizer such as ammonium nitrate or urea. Other sulfur sources are single superphosphate SSP, potassium sulfate, SOP and potassium magnesium sulfate kyanite, the latter also containing magnesium. Kieserite is a magnesium sulfate mineral that is mined and also used as fertilizer in agriculture, mainly to correct magnesium deficiency. Calcium is mainly applied as calcium nitrate, gypsum, calcium sulfate, or lime, dolomite, calcium carbonate, of which calcium nitrate is the only readily plant available source of calcium. Organic fertilizers. Crop residues, animal manures, and slurries are the principal organic fertilizers. Although they have varying nutritional values, they are generally present on the farm, and the nutrients and the organic carbon they contain are recycled. Animal manures and slurries cover a wide range of nutrient sources with different physical properties and nutrients contents. Furthermore, their nutrients contents vary regionally and depend on the type of livestock and the farm management system. These are the difference between conventional fertilizers and nanofertilizers. On my very left hand side, these are the main points and difference between, according to these points, between conventional fertilizers and nanofertilizers. So first of all, if we discuss or talk about loss rate, in conventional fertilizers, high loss rate were drifting, leaching, runoff, but in nanofertilizers, low loss of fertilizer nutrients. The controlled release. In conventional fertilizers, excess release of nutrients led to high toxicity and soil imbalance. But in nanofertilizers, rate of release and release pattern precisely controlled. Solubility. In conventional fertilizers, the solubility is low, but in a nanofertilizer, solubility rate is high. Bioavailability rate in conventional fertilizers is low, and in a nanofertilizers the bioavailability rate is high. Dispersion of mineral micronutrients in the conventional fertilizers is lower solubility due to large size particle, because the conventional fertilizer has the large size, but in a nano fertilizer it's a very small size, approximately to 1 to 100, between a 1 to 100 nanometer. In a nano fertilizers, dispersion of mineral micronutrients is improved dispersion of insoluble nutrients. Effective duration of release. In conventional fertilizers used by the plant at the site and time of application, the rest is converted into an insoluble form. But in a nanofertilizer, effective duration of release is effective and extended duration, have a effective and extended duration. The efficiency of a nutrient uptake. In conventional fertilizer, it is not available to roots, and the efficiency of nutrient uptake is low. But in a nano fertilizer, the efficiency of nutrient uptake is have a enhanced uptake ratio and saves fertilizer resources. Soil adsorption and fixation. In a conventional fertilizer, the conventional fertilizers have a high soil adsorption and fixation, but in a nano fertilizer, the soil adsorption and fixation is reduced. These are the references of my presentation data. So thank you so much. That's all done from my side. Allah Hafiz.